So when I think about the challenges that we have of making these very capable prosthetics available to everybody, it really becomes a matter of changing the way we look at prosthetics. So the most important data that we've gotten in prosthetics design is really an understanding of how the human limbs work. And because what we try to do is make prosthetics that really feel like a natural limb.
Our ultimate goal is basically to reconnect and integrate the prosthetic device as best as possible to the human body. The prosthetic device should become a natural extension to the human body. And in order to do that, we need to figure out the best way to reintegrate the device to the body.
So if I think about what I want to do with my hand, or what you want to do with your hand, I do very complex things all the time, and I hardly even think about it. And we really want to use data to kind of capture all the things that we might want to do. Play golf, play the piano, type on a keyboard. If you're holding a glass and it begins to slip, you just tighten your grip on it. You don't think, oh, the glass is starting to slip, I need to tighten my grip. You just do it. Very difficult to do with today's current generation of prosthetics. So what we've been doing is using machine learning in order to essentially learn how to do that task. So now you just think, I want to pick up the tool, and the arm understands how to actually form the grasp, position itself to get the tool, and then actually operate the tool. So what big data can help us with is the ability to offload a lot of the burden off the brain. I just say, hey, I want to wiggle my fingers. And as we get more and more information about the types of motions and the way people do things, we can capture that in big data. So that it's just like anything else. Once you've learned it, you don't have to relearn it every time.
So becoming an amputee in 1996, pre-internet, pre-email, pre-data era, I have seen a lot of advancements over time. Over the last 20 years, the advancement has gone from mechanical to more electronic, bionic type devices, microprocessor controlled, if you will. With that, we are utilizing processors, sensors, to provide input to the prosthesis, to then allow the prosthesis to react and respond to whatever situation the user finds himself in.
Traditionally, a prosthetic user has to look at the limb, the prosthetic, in order to use it. And that's actually one of the biggest complaints that they have. So what we've been able to do is actually stimulate nerves to actually create sensation. And so now when somebody grasps an object, they actually feel it, and they can feel the pressure.
I believe data is the core of this type of further development. If we wouldn't have the data, if we can't interpret the data, that is in this case coming directly from the human body, we would not be able to take the right decisions for the patients. So I think it's definitely a data-driven future vision, and I think that further analysis will have to show how we can do it in a proper way, how that data can be further processed to then allow for quick decision making, and decision making that will come to the benefit of the user, to allow them again to live their life without limitations.